Good afternoon, everyone. Glad to see all of you are here, and we've got the first assignment out now. And so in the first part of today's lecture, we're actually going to take you through that, give you plenty of time to understand what's going on, before in the second half of the lecture, I'll give you a few more C tips related to structure and memory management that will help make your life easier. So for now, I'm going to turn it over to John. Can we have a warm round of applause for him coming back? I will see you all in a little bit.
Hello.
Let's switch your screen. There we go.
Just when you thought you're going to have Shannon for today, you got me. At least for the first 30 minutes. I actually have to, I'm going to talk about assignment 1 for the first 30 minutes of the lecture. After that, I actually have to go to one of the major milestone progress meeting for one of my PhD students. So I'll have to go in the middle. Not that I don't care about you, but they are also worrying about their progress. I can't keep them waiting for too much. Okay, assignment 1 is out a couple of days ago, and it's going to be due on Tuesday, 30th of April, which is about 2 weeks away. It's going to be due in 4 p.m. in the afternoon, such that if you have some questions asked overnight, I know you only work at night, so I can answer them in the morning. That's why we did that. The assignment package, you can download them in LMS. If you go to our LMS site, click on this assignment link, and it will land you to this page. And if you click, continue to click on this one, you'll see an assignment package which is downloadable. The submission will also be through this site. We haven't really get the whole submission activated yet, but when the submission is activated, which we will announce that, you will see a button in here. And you click that button, you follow the links, and you can submit. Here, I'm going to show you a setup of last year's version, how it looks like. So this is a 2023 setup, but this year will be very similar to that. There's a button in here where you can click it, and if you click it, it links you to, again, this is 2023 site. Go to the Grayscope site where there's assignments. Here, you will only see assignment 1 for now, and if you click on that, it leads you to a page where there's a link. You can upload your program, and you click upload, and you click submit, and that's it. Submission part is fairly straightforward. The more important part is what really is about this assignment. So the assignment here has something to do with a search problem. So in the lectures, we cover binary search, right? And if you have a telephone book, you want to find a sort of someone's telephone number, you can do this ripping off by looking at the middle part, and then you recursively do this, keep ripping apart, and then in the end you will find where the particular person's telephone number is in the telephone book. Now, that's all right, but the assumption there is you got kind of a one-dimensional kind of values, right? But what happens if you have data that is more than one dimension, and the search criteria is not really the name of the person, but you need to search not only the name, and then, for example, I don't know, the occupation. You have multiple search criteria. Then how can you organize your telephone book? And that's what we're going to cover in this assignment. When you have this kind of multiple search criteria and multiple sort of sorting order, we simplify that, not considering all these people's names yet and all their occupations yet. Here we're just looking at numbers, and numbers essentially becomes a sort of a number, a point in a multi-dimensional space, and that maps to a sort of digital mapping application. Think about looking for things in Google Maps. I would imagine everyone would need to use Google Maps or this kind of mapping services at least once in a month, probably, right? Now, for example, here we consider to look for cafes around. Here is our Melbourne campus anyway, Melbourne Uni campus anyway. Now, if I sort of want to explore my area a little bit, I go to this area and I will see, like, show me the cafes in this area. Then I have to click this button, and then the cafes got show up. And they don't got show up instantly because there are just so many cafes, because it's not just because Google Maps is providing service to everyone on the world, essentially. There are so many cafes on the world, and how do you know which are the cafes in this particular area? That's the problem that we're going to address in this assignment. And you're going to be given a set of points and a set of areas that you want to look up the points in there. You can think of these points, each of them, you can think of them as if they're representing a cafe's location. So if you plot them on a two-dimensional space, each of these little cross in here, they represent a point in the input. And to simplify the assignment, we assume that in each input file, you're going to be given 50 point of interest. We call it POI, point of interest. You can think of a cafe or a restaurant, or I don't know, could be a sort of charging station if you're driving an electric vehicle, and those all kind of things. And each of these points, they come within 3 fields. The first field is its ID, and it's a unique integer. And we assume that all these IDs are just already ordered from 0 up to 49 in here. And each record is separated by a semicolon. Now, the first number is the ID. The second and third numbers are the coordinates of these points, right? So that's 50 points, and we give you a sample plot of the 50 points. And this made up for the first 10 lines of the input for the assignment. After that, we give you another 5 lines of input. Each of these 5 lines, they represent a rectangle, a range. It's just like in the map scenario, this is like the range, a rectangle that we want to show all the cafes in. And because the map, you can think of it as like super large plane, and here we are only showing a part of it. And in this case, there are 4 this kind of rectangles, such ranges. We call them range queries anyway. There are 4 such ranges, and each of them is represented in here. To give an example, how does these 4 numbers represent a rectangle? The 4 numbers in here represents the boundaries of the rectangle. In this case, the first 2 numbers are the lower bound. The x-axis is lower bound, and the y-axis is lower bound. So 11.8 is pretty much this point, and 3.5 is pretty much this point. And similarly, these later 2 numbers, they represent the upper bound on the x and y dimension. So 53.5 is this point, and 28.5 is this point. And these queries, they are numbered again starting from 0 up to like, because we are only going to be given 5 queries, so the queries are also numbered from 0 up to 4. So far, so good. That's the setup. Now, for the first stage, all that you need to do is really just to understand a skeleton code file that we're going to give to you. So if you download the package from the assignment website, the package contains these following few files. So if you download it, you got a zip file. And if you unpack it, you got a sort of assignment 1 package. And it contains the following files, including this PDF file, which is the assignment spec that we just shown you, and then the assignment marking rubric, which I'm going to show you in a quick moment. And after that, it's a skeleton file that contains a standard, a sort of a starting point, a starting template for you to code up assignment 1. And your stage 1 is mostly just to read and understand this template. So if you open it, it looks something like this. It already has some 200 lines of code. It's quite a bit of reading. If you look at the main function, it looks like this. There's some sort of data declaration, some variable declaration, which are supposed to use to hold the data to be read in. Obviously, we haven't really given you the code to read the data, but that's what you need to do for stage 1. After that, there's a few functions. Each of them handles one of the stages of the assignment. So in stage 1, your goal is to read the input, the 15 lines of data that we just showed you, and read them into these variables. And after that, we want you to tell me, among these points in the input, which are the points in the first query rectangle. We show it in red, but it's just the same as any other query rectangle anyway. It just represents one of the queries. And for stage 1, we want you to only look at the first query. So how do you know which are the points in this query anyway? What would be your solution? You're given a set of points, you're given a rectangle. Tell me which are the points in the rectangle. How would you do it? How would you approach it? Yes.
See if the x coordinate is equal to the range of minimum and maximum x coordinate. Then compare it to y coordinate in range of maximum and minimum y coordinate.
Anyone else hear that as well? Yeah. So the idea would be, well, you are given this set of points and you're given a rectangle. How do I tell which are the ones in the rectangle? I'll go through each of the points and ask, are you in the rectangle? Are you in the rectangle? Are you in the rectangle? And in the end, I'm going to tell you that these are the points that are going to be in the rectangle. That's just the idea. It's just like the linear search case, right? It goes into the every entry in the telephone book. Is the name of this entry match the query person? Is the name match the query person? Is the name match the query person? Same idea. Here it's just that is the coordinates within the range. Is the coordinates within the range, and so on and so forth. We did this for every point. And this is a perfectly fine solution. Now, how many points are you going to compare with this query rectangle to answer the first to answer this problem? We got a total of 50 points. And in order to find these 2 points inside of rectangle, how many points do we need to compare with the rectangle? We got a total of 50 points. And I want to tell these 2 points are in the rectangle. How many points do we need to check? All of them, right? You have to check all of them, 50. And 50 is not too bad. But if you think about Google case, how many cafes are there? It's not just a cafe, right? People can create anything. And there's millions or probably even billions of these kind of things. And there are billions of users submitting these kind of queries. We know Google is like having a lot of servers, but still it's going to be a burden for them. So we need to design smarter solutions for this. And that's what's going to be for stage 2. For stage 2, what we want you to do is, if you look at this point, actually, we can take advantage of the x coordinates and do this kind of filtering quickly. If you think about it, if I go through all the points and look at their x coordinates only, if their x coordinates are not within this range, we don't need to check their y coordinates, right? And that's the idea. So what we are going to do is that we're going to sort the points based on the x coordinates. And once the points are sorted in x coordinates, all that we need to look at is just the points starting from this moment up to here. Anything else, we don't need to worry about them because we know that these points must be beyond the upper bound in the x coordinates of this query range. So for this first query, by using this sorting based on the x coordinates and querying based on the x coordinates, we pretty much cut half the points from the checking. And similarly for these other queries, you can also cut the number of points that you need to check. And that's stage 2. We ask you to process the query. We ask you to sort the points based on this x coordinates. And based on this sorted array of POI points based on the x coordinates, we ask you to process all 5 queries. And we ask you to tell us that how many points do we need to check to answer each query. And obviously, for now, for the first query, we throw away most of the points because they are beyond the boundary in the x coordinates. We pretty much only need to check the points within these 2 boundaries, the lower bound and upper bound in the x coordinates, in the x dimension. So there are about 17 points in here. So for the first query, we still need to check for 17 points, but that's already a lot smaller than the 50 points that we have to check. And in here, you might think that it's just cutting by half, it's no big deal. But the issue is, again, if you think about this problem in a global scale, the query range typically is not so huge compared with the whole globe. In here, our query range is almost like half of the whole globe. But in reality, people wouldn't query for half of all the cafes around the globe. It's not like that. It's more like any queries that you can see is more like this Q3 in here, just tiny little bit. And using this sorting by x coordinate, it can already help boost the efficiency quite a bit. And we don't stop at there. We want to say, well, if you only look at the x coordinates, there's still quite a bit of false positive in the sense that all these points which are actually outside the boundary in the y coordinates of the query range, we also want to find a way to not look at them. And in order to not look at these points, well, we know if we sort the points based on the x coordinates, we can quickly throw away the points that are outside in the x boundary. So if you also want to store the points outside the y boundary, then naturally you want to sort the points based on the y coordinates. So that's what we are going to do in the third stage. In the third stage, we want to sort the points based on the x and y coordinates together. And to make that sorting work, we introduce a technique. The actual concept for this technique is called space filling curve. There's a space. Here we got a space. And we want to fill this space with a curve. That's called space filling curve. Now, how does this space filling curve technique work? What it does is it breaks the space into a rectangle with a sort of a regular grid. Here we are breaking it into an 8 by 8 grid. And I'm going to plot a curve that goes through each of these grid cells once and exactly once. This curve in here, look at it, it has a Z shape. This is actually called a Z curve. And we are going for this Z curve. And it's actually a recursive Z shape. You can see that looking at the 4 cells in here, there's a Z. And if you look at these 16 cells, they actually looks at a Z curve. And if you look at the whole thing, it's also going from left to right, and then go back, go left up, and then go to the right. So it's a recursive Z shape. This is actually a factual shape anyway. Now, once you set up this curve, we can number the cells in the space by the order that this curve visits the cells. So starting from the first cell, this is the starting point. The top right corner is endpoint. The first cell has a number of 0, and then 1, and then 2, and then 3, and then 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth. And we give a number of every cell. Now, once we got the number for every cell, for every point in these cells, they got this number. So, for example, this point we got a number 0. This point we got a number 3. This point in here we got a number 33, and this point in here got a number 63. So each point gets a single number. Now, once every point gets a single number, our binary search can kick in again. So what we did in here is, for every point, we give them this curve value, this number that we give every point, we call it curve value. We give every point a curve value, and then we sort the points based on the curve value. Now, some of the points, they might be sharing the same cell, they will have the same curve value, but that's fine. We can break the ties by the points ID, that's fine. But in stage 3, you don't even need, in stage 3, what you need to do is to write a function that, given a point's coordinates, your function should return what's the curve value. The actual calculation is not very straightforward. We already gave you part of the implementation. You only need to implement the other half. And the half that you need to implement is, given a point, you need to figure out which row and which column it is in. For example, for this point, it's in like row 0 and column 0. And for this point, it's in row 1 and column 1. And this one is in row 0 and column 1. This row number and column number together will be given to calculate the actual curve value in here. That actual calculation you don't need to worry about. We gave you that function already. You just need to calculate which row and which column it is for every point you're given. And that's your stage 3. For every point, calculate their curve value, and then you sort the points based on their curve values. And last stage is really, once you got all these curve values for the points, we're going to do the search using binary search. Then you might be wondering, well, how do I know, for example, given a query like this, how do I know what kind of search should I perform? What will be the range that I want to look at to locate the points within this rectangle? Now, the interesting bit with this space filling curve, this curve, is that it's always kind of going from the bottom left to top right. It's always going like that. If you look at here, this value is smaller than that. It's also smaller than that. And both these two are also smaller than that. And exploiting this property we'll see that if you want to find the points that are within this query rectangle, all that you need to know is to figure out what's the curve value at the bottom left corner of this rectangle, and what's the curve value at the top right corner of this rectangle. And for this query, it's between 0 and 24. So if there's a point that is supposed to be within this query range, its curve value must be between 0 and 24. And obviously there's some false positives. You see these other points, they are actually also within 0 and 24 because the curve between 0 and 24 will go through all these cells and up to here. And all these things are actually beyond the query range. So those are the actual costs that you have to pay using this curve filling kind of technique to do the search. But in general, using this technique, we are going to be achieve a faster query processing time and more intuitively to see how expensive is a query. Using these different query techniques, we see how many points in the query we need to test whether it's in the query or not. As you can see, for the first query, actually we are worse off using this space filling curve technique. We need to compare 19 points. The previous one, we only need to compare using the x coordinates. We only compare 17 points. But for the later ones, for example, here we need to compare for the third query, Q2, we need to compare for 24. And in here, we cut that into just 18 comparisons. And for others, for the last one, we cut that into only 5 comparisons. So there's no perfect solution actually, because now we are going beyond one-dimensional. And then when you have more than one-dimensional in your data, there's no perfect order. And because of that, you have to sort of try to balance. And given different kind of queries, you might want to use different kind of sorting techniques. But that's pretty much the assignment. So far, so good. Any questions? Yeah?
Why is an 8x8 grid?
Very good question. Why do we use an 8x8? We could use a 4x4 as well, and we can use a 16x16. The only thing that if you use a 4x4, the issue is you're going to have many points all stay in the same cell. Then they all share in the same curve value. Then the binary search is going to help you to filter a lot of points because they all share the same value. And why don't we go for 16x16? That's too many for me to draw. That's just the only reason. Yeah.
Because if you expand the grid, that makes it so that it's a less likelihood that you have multiple points in one point.
Exactly. We can certainly go for 16x16. And actually, when you actually want to deploy this technique into a real system, you need to think about what's the right number of cells in there. You might think that smaller cells are always better, but it's not. If you have very small cells, the chance is that many of the cells has nothing in there at all. But still, you need to manage them because you create such a grid, and that's not great as well. And there's a lot of study in there how to put this into a practical use. Now our assignment is a simplified version. I don't want you to worry about that. I'll just say let's go for 8x8. Anything else? Yes.
We would sort the image sorts like applies to all this line like against values. So stage 2 we have to compare the x values.
Can you speak louder? I can't.
Stage 2 we have to compare the x values.
Sorry?
So you know in stage 2
Yeah.
the x values.
Yeah.
We have to sort the inputs first.
Oh, definitely. Yes, definitely. For stage 2, for stage 1, you don't need to worry about that. It's already sorted by the IDs already. For stage 2, in order to exploit these x coordinates to filter the points, you have to sort the points based on the x coordinates.
We have to sort them first.
Yeah. So stage 2 is sorted by x coordinates, as the stage heading says. Like, you need to do the sorting. And then stage 3, you need to do a sorting again, this time using a different criteria. Anything else? Yeah.
What if that multiple points with the same values? Like with the same curve values? Yeah, curve values.
You mean curve values? If you have multiple points with the same curve values, you can break the type by their unique IDs. Anything else? If not, then that's the assignment spec, and we also cover the sort of the skeleton code as well. In the skeleton code, we basically give you just the function names, and you still need to complete the function body. There's one special function that I want to mention. This is the function that we gave you to calculate the curve value given a point's row and column number. You need to figure out which row, which column it is, and then this function will calculate what is the curve value. There's a bit of, these are the bitwise operators. If you really want to figure out what's going on, you need to read chapter 13 of the textbook. We also asked you to implement a bit of binary search. We gave you the starting template of the binary search. You need to modify based on this one. That's the skeleton code. The test data we also gave you in the form of two test input data, test 0 and test 1. We actually gave you sort of two test cases, two sample test cases. Both of them contains like 10 lines of points and 5 lines of queries. We also gave you sample output for these two sort of input files. Now, to run and compile and run this code, what you need to do is like you go to the folder that that is unpacked from the assignment package. You say gcc war-o program and program.c. Later on, you will need to use the math package to use the math library. Use -lm to compile the code. And the skeleton code file already compiles, and you can already run it. When you run it, it doesn't do anything because it's waiting for you. Well, actually, it does something. It just print out the stage headers. Now, after you finish sort of your coding, you can you keep modifying this program, right? And after you finish coding, you can do this kind of testing. And to fit the data into your program, one way to do it is just copy and paste the test 0 file into the terminal, but that's not so convenient. Another way to do it is you say program left angle bracket test 0.txt. By doing so, the file content of test 0.txt will be fed into your program and be used as the terminal input. So you don't need to type in the numbers. Just do this, what we call input redirection, and it can still run. So that's the sample code. The last thing I need to mention, well, so far so good. Any question? Yeah. The last thing I want to mention is a marking rubric. This is also part of the assignment package. There are 4 sections of the marking. Hopefully, we don't need to use the first section, but if we have to, I won't hesitate to do it. So trying to do the assignment on your own. This is an individual assignment, and we have sophisticated software to check whether your submission is similar with someone else. And when we found issues, we will take actions. Make sure that you put in your student name and ID at the top. So here in the program.c file, we actually gave you a place where you fill in your student ID and name. This helps us to automatically recognize the assignment and match with your profile. We also ask you to use the binary search code that we gave you and then do the implementation based on this one. A few parts of the marking. There are three more sections. I'll talk about the last section because it's probably the easiest. The last one is the program execution. We are going to test your submission with 2 hidden test cases. We gave you 2 sample test cases. In the marking, we are going to test it with 2 hidden test cases, which you haven't seen yet. And and each sort of the test cases was a few different marks. And this is just a simple matching of your program output. Now, the other 2 sections of the marking is sort of more subjective. It's your code style. For example, we ask you to, if you're going to define constants, you have to define them using uppercase letters. Give an example. Here, we define a few constants. All of them are in uppercase letters or underscores. So if you do that, you also need to follow the same sort of style. Now, right, this is the defining uppercase one. The other is, if you want to use some constants, you need to define them. Like here, we use this 1, 2, 3, 4, 5, and 50, and 2, and 5, 4. We define all this as a defined constant before we use it. Function prototypes. When you use a function, you want to sort of put their names at the top and sort of create a function prototype. That's a requirement. Actually, this might be a bit easier to show. And bad choice of function names and variable names. These are just saying that when you create functions and variables, use meaningful names for them, not just use meaningful name for them, not just like A, B, C. That doesn't mean anything, and that's not helpful. You also want to put comments to your code. In here, you pretty much need to follow our standard. What we have done is for every function, we gave you a piece of comment to explain what this function does. That's the minimum that you need to do. If you create more functions, you need to explain for it. But in the meantime, you also don't want to overdo it. Don't try to add a comment to explain every line of your code. That doesn't help. Bracket placement and indentation. These are more about really it's just about consistency in the sense that if you decide to go with one kind of placement of the brackets, follow that through in the whole program. For example, in here, my style is really we put the opening brace at the end of a line and we put the ending brace at the beginning of a line. You don't have to do this. You can also put the opening brace at the beginning of a line. I'm fine with that as well. The only thing is, if you want to go for this style, you have to flow it through as the whole program. You can't do it this way in one function. In the next function, you use my way. Then that's called inconsistency. Similarly, for the indentation, it's the same. Give an example here. For example, I got these two lines. Both of them belongs to the for loop. Then they should be indented by the same level. You can't do sort of one tab for this one, and for the other one, you indent it for one level. That doesn't make sense. Think of it almost like writing Python code. You want to follow the indentation rule of the Python code, essentially. Lack of white space. This means that you don't want to put all your code all crammed together. You want to give a few blank lines to separate different blocks of your code. For example, in here, we have a line to separate every function from another. Even within the same function, here we still separate different blocks of a function. That's what you need to have. The lines shouldn't be too long. If the lines are too long, when we want to read it, we have to go from like score left and right, and that's not so convenient. So the number of characters per line shouldn't go beyond 100 characters. And we also gave some sort of blank clause saying that if we found any other issues, potentially we can take marks. We tend not to use these two final clauses because they are quite relatively subjective. That's just it. Final bit, there are also structural issues, not just like the style. Here, if you have duplicate code segments, then that means you really want to create functions for them. Such instead of repeating the same piece of code many times, you rewrite a function and then you keep calling the function, right? That's that. And you are not supposed to use global variables. If you need to use some variables, put them in main and then pass it into different functions. Insufficient use of functions. We already sort of gave you quite a lot of functions. We asked you to create at least 2 more. And functions shouldn't be too long as well. Just like in the lines case, you also don't want a function that's too long. If it's too long, we have to go up and down to see the whole thing, and it's also not so great. Overly complex algorithmic approach. If you just want to do a linear search, don't do it with 2 loops. 1 loop is enough. That's what this overly complex algorithmic approach means. And unnecessary duplication and copying of data. If you can do all operations on one array, then don't duplicate into another array and then try to modify the second array. No point to do that. Just modify the original array already. If you are going to use type defs, you're not required to. If you use it, you have to define it using _t. And if you want to do some equal testing for doubles, you should not use two equal sign to do the testing. Otherwise, you will cause issues. I don't believe for this assignment you need this anyway, but just in case, we sort of put it in here as well. So that's the marking rubric. Any questions? Yes. Can you speak louder, actually?
You like for swapping and sorting the data,
Yeah.
the 2D array, you
Yeah.
would be working with double thing.
Yes.
And it won't work on the in swapping the zero.
Yeah, right, exactly. If you are gonna need those kind of things, you have to create another function.
You can make bigger than what
You could, yeah. Here we already gave you that permission already. We say uh, for the insertion sort and part of it, you could create another one if you need it. Yeah. Yeah.
how detailed should I comment?
Sorry?
How detailed do you want to comment?
It doesn't have to be extremely detailed. Definitely not longer than your code. Yeah. And, yeah. Anything else? Oh yeah.
We have library.
Add libraries. Well, if it's C standard library, yes. You are not supposed to add further like your own sort of private libraries. You are supposed to only upload one piece of code, the program.c file. Yes.
How do you code this?
Yes, that's what we sort of answered at the beginning. So after we set up the submission system, there will be a button in this assignment 1 page, and you click on that button, you follow the link. Yeah.
And we submit the entire thing in one file.
Yes, entire thing as one file. Just program.c. You don't need to submit the data or the marking rubric or the assignment spec. None of those. Just program.c. Yeah.
So the format for like animating student number, the first name, space, last name, space, student number.
Yeah. As long as you put your name and student ID in here, we are not super sort of pedantic in terms of exact format of that. As long as you have a name and ID in there, we actually we do a bit of automatic recognition and then human sort of post checking. Anything else? Yeah.
If at some point you are implementing one of the options that is in the textbook, because it's option.
Right, very good question. If we are going to use functions from the textbook, what we are going to do? Here's what we are going to do. We declare that this is a bit that we sort of get from that source. Anything else? Yes.
So we will define constant of any functions, which exact condition like every sub functions and constant everything like at the beginning of the program.
Typically, constant definition goes at the top. And function prototype, we also gave you a section where you can put your function prototype. Yeah.
What about the function itself?
The functions themselves, typically they go just below the main function. And then exactly where are they doesn't really matter. Anything else? If not, I suppose I will pass on to Shannon such that he can also talk a little bit about the lecture stuff, not running the whole thing. Yeah, over to you.
Thank you very much. I'm also particularly excited about this assignment because it builds on some of Zhang's research area. And so not only are you getting an assignment that like kind of tests your own skills, you're also getting an opportunity to see something that really gets done in the real world and that relates to some more complicated concepts that you'll explore as you make your way throughout the world of computer science. See you later, Zhang. Good afternoon, everyone. We've got just a few things to talk about in a couple of minutes that we've got available today. So if you remember yesterday, we were talking quite a bit about more advanced ways that we can use memory. However, it was getting a little complicated. We'd introduced malloc, we talked about having to manually manage memory, and things would go wrong pretty easily. In fact, if we were not particularly careful, if we misuse our memory, we would either get set faults, or you get memory leaks from when you had allocated memory, but it hadn't actually cleaned up after yourself. So what are we going to do? Well, fortunately, computer scientists have been dealing with this kind of problem for decades now, and so we have a number of tools that are available to us to actually make it somewhat easier. So the first thing to know is that compiler errors are what we call static analysis. So this is where you have a block of text, you run some analysis on the block of text, which is what your compiler is going to do, and then it spits out a bunch of errors. It might say, oh, maybe you've got a semicolon at the end of this line. Or maybe just by looking at the text, I can see that you exceeded the bounds that you allocated for this array. Now that works very well for like statically declared arrays, so the compiler knows ahead of time how much memory there's going to be. But what if you're doing something like malloc, where you're using a variable to determine how much space you're going to allocate? Well, then this kind of like textual analysis technique isn't going to work so well. So the compiler is one tool that works very well for some errors, but for other types of errors, we're actually going to need dynamic analysis. So the basic idea is you run the program, and you have some other tool that's carefully watching your program. Maybe it measures how much memory your program is using, and on the basis of that, you can track maybe if you accidentally gone beyond the memory that was given to you, even if it didn't trigger a set call, or if in fact that you allocated memory and then forgot to free it up later. So let's see a couple of examples of this and actually try it out with some code. So when you're writing code, you can run these same tools on your computer and see where memory errors might be. So here's an example of bad.c. I'm going to leave this for you to download, and one thing I want you to do is play around with each of these examples and see which errors you can catch by static analysis and which errors you're going to have to catch by dynamic analysis. So the first thing I'm going to do now is I'm going to open a series of demos, and I'm going to show you how to catch those errors before we turn to one small thing that I actually care a lot about for the end of today's lecture. So here I have my terminal, and I am going to open leak1.c. And in leak1.c, I'm going to do a loop 1,000 times. I'm going to malloc an integer, so I'm going to malloc 1,000 integers, and then I'm going to store the value of I in the allocated memory. So integer 1 is going to contain 0, integer 2 is going to contain 1, integer 3 is going to contain 2, and so on and so forth. So let's run this and see what happens. So no complaints from the compiler. It hasn't detected anything wrong. Let's see if I do this. Still nothing. So not even enabling all my errors is going to get the compiler to detect what's going on here. Now, I should say that very modern versions of the compilers do have some fancy flags that will run more sophisticated analysis, but I'm not going to focus on those for the time being. I'm going to run one that comes built into Mac OS. There's another tool for Windows and Linux that I'll show you shortly. But for now, let's run the Mac one. It's called leaks. And what we do is we pass it this sequence of commands at exit, and then the name of the program. So you'll notice that I've also added this dash dash. What this means is the rest of the arguments that follow are actually for my program that I'm running and not for the leaks command. So now let's run that. Something like leaks won't work. There we go. So it now gives us all the complaints about the leaks from the program, and there are so many of them that I have to scroll down a long way. Let's see if I scroll back up here, do I actually get a trace? Yeah. So essentially what's happened here is the leaks program has detected the leaks and has told me exactly what's in the leaked memory. So I can see that it's going through the different ASCII bytes of each of the, because I've said from 0 to 1000, 0 to 1000, the first few characters of that are all going to be valid ASCII. And so I can see here that I've leaked one integer that was equivalent to S, one integer that was equivalent to T, etc., etc. So this tool is useful for detecting if you have memory leaks, although it's a little harder to get it configured to actually show you where the leaks are. Now, the next tool that I'm going to show you won't actually run on Mac OS, at least on modern versions of Macs that have an M1 chip, because this tool is only available for x86 machines. So that's the kind of machines that most Windows computers run on. So now let's switch back over to here and see what my error was. So I have forgotten to free all those values, and so what I could do is I could now do another command over here, and do free A at the end, and now I've solved this memory leak. What about leak2.c? Oh, actually, let's skip that. Let's go to leak3.c. So here, what I now have is now I've got some memory that I allocate in main. I use it in, I have some memory that I allocate inside this function allocate array. Then I use it inside my main function. I use allocate array, but again, I have missed my freeze. So if you look carefully here, you'll see inside allocate array, I'm creating the array. And then in main function, I'm using the memory that I've allocated, but again, I haven't freed it. So one of the challenges that I'm going to leave you with for homework is to again track down this memory leak and solve it by putting a free in the right location. And we will leave it at that for memory leaks. Let's see if I have bad.c somewhere around and we can see the one other tool. Here we are, bad.c. So here is a memory leak example where I have just forgotten to add my free after creating this string. Here is a use after free example. This is another bug where I have freed the pointer, but then I attempt to use it again. Other memory examples in this file that you can then go through. I've created an array of length 5, but that means it goes from indexes 0 to 4. And so in this loop, you'll see I have this equals here, less than or equals to, which means my I goes all the way up to 5. And because the index of the array only goes up to 4, I'm accessing outside the bounds of my array. And here I'm doing another similar-ish kind of thing where I'm adding 1 to an integer that's already the max value of the integers. So let's compile this and see what happens. So it actually runs, which is a little worrying to us because we know, because we've just gone through it, that there are all these errors in it. So again, I'm going to try the fancier version of the Clang for flags. And now we'll see if it can pick up any of these errors, because it wasn't able to pick up the memory leaks. But there we go. It was able to pick up the use after free. So this is the output. You can see it says previously allocated, bad.c line 11. So it tells me where I originally allocated the memory. It can tell me where I freed it. And then it also tells me where I attempted to use it after I'd freed it in the first place. So using these tools can be a really powerful way of tracking where you've gone wrong and then sorting some of these bugs. And depending which bug you're tracking down, you might have to use a different combination of flags or a different combination of tools. The presence of Valgrind on Linux, though, and it works on the emulated Linux on Windows, but not on Mac, is a good reason to try some of your development on a different architecture so that you can run Valgrind, because it is a very useful tool. So here I've run the Valgrind command, and this video will be available for all of you that I'll upload after. And you can see what it's actually done is it's told me in detail that in bad.c on line 14, there is memory that was not freed, that was originally allocated at some other location. So you can actually use the Valgrind tool to tell you where in your program you allocated the memory that you've forgotten to free. And then it will tell you it's definitely lost 10 bytes in one block. So this is in the bad.c program rather than the leaks program that I just showed you. Yes, Jack.
Still working.
It should, yeah. It'll still work. The Clang one isn't architecture specific. It's just the Valgrind is, and leaks is only for Mac. And so I use leaks if I'm impatient and don't want to try putting my code on a Linux machine. There are ways to get Valgrind running on a Mac inside an emulation of a Windows thing or inside an emulation of a different architecture, but it's generally more effort than it's worth. So in the last 1 or 2 minutes, I'm just going to give us a sneak preview of next week's lecture because there are 1 or 2 important things about today that we need to know. Okay, so better than messing around with all of this, all of these toolings and all of this like challenging managing memory, the best thing we can actually do is use other programming languages which solve this problem for us. And there are programming languages that are designed to be as powerful as C, because C gives us a lot of access to the system, but also without letting us shoot ourselves in the foot. So languages like Rust, which is they're experimenting now to write portions of Linux in, and Go, two examples of memory-safe languages that are still useful for the kinds of things that we use C for. Java is a bit too slow to use in many of the places where we'd use C, even though it's memory safe, and that's the same for Python.
This has been the most extraordinary experience of my entire life. We're about to go on a little adventure together, and that adventure is going to span 17 years of music. How does that sound?
So who knows why I was showing this today? Anyone? Thank God someone in the audience knows. So in approximately 15 minutes, Taylor Swift drops the Tortured Poets Department, which is her new album. And to celebrate, the rest of the semester is going to be Taylor Swift themed. So for our next lecture, we are going to discuss this challenging problem, the fairest way to discuss Eras tour tickets. And for those of you who are not familiar, the current tour that Taylor Swift is going on is called the Eras Tour. And so with that, have a great weekend. I will see you next Friday to discuss Taylor Swift.